In this video, we will solve this system of equations using Gaussian elimination. The difference between Gaussian elimination and Gaussian-Jordan elimination is Gaussian elimination, our goal is the reduced echelon form, meaning that we want ones on the diagonal and zeros below all of the ones. The other values do not matter. In Gaussian-Jordan elimination, we want reduced row echelon form. So in addition to this form, we would want zeros above and below all the ones. So after writing down our goal, the next thing we want to write down is our answer. And you can obtain your answer by using your graphing calculator and the matrices function. Now we want to write down our augmented matrix. So we want to take our current matrix, take our current system of equations and write down all of the coefficients for the variables and all of the answers in the last column. Now what we're going to do is we want to be systematic in the way that we approach solving this problem. So systematic means we're going to start and do everything in this first row. So 1 in the first row, we have that. Next row we have 0, but currently we have 3. So performing our row operations, there's only 3 things that we can do. We can multiply a row by a number. We can add or subtract rows from one another, or we can combine those two and you can do a multiple of a row and then add or subtract. So what we want to do here is 3 times row 1 minus row 2, and we're going to store this answer in row 2. So our rows that are going to remain the same are row 1 and row 3. And the row that's going to change is row 2. So we're doing 3 times the first row. So 3 times 1 gives us 3, and 3 minus 3 gives us 0. 3 times a negative 1 gives us negative 3. Negative 3 minus 1 is going to give us negative 4. 3 times 2 is 6, and 6 minus 5 gives us 1. 3 times 4 is 12, and 12 minus 19 gives us negative 7. Now, we want to look at the matrix that we currently have and compare it to our goal, 1 on the first row, 0 below it. Now let's look at the third row. We need a 0 here. So we can never multiply by 0 because that just changes the whole entire row to 0, and we would never get a 1 there. So we want to use the same strategy that we used before. We want to multiply 2 times the first row and then subtract the third row and store that answer in the third row. So our rows that are going to stay the same, the first row and our second row. So we're now going to multiply the top row by 2, 2 times row 1, and then subtract the third row from it, and the answer we're going to store in row 3. So 2 times 1 gives us 2, 2 minus 2 gives us 0, and that's our goal. We want 1 on the first row, 0 followed by another 0. 2 times negative 1 gives us negative 2, negative 2 minus a negative 1 And remember, a minus and a negative together changes to a positive. So negative 2 plus 1 is going to give us negative 1. 2 times 2 is 4. 4 minus a negative 2 gives us positive 6. And 2 times 4 is 8. 8 minus a negative 19 is going to give us positive 27. So now our first goal, our first column, we have 1, 0, 0. Now in this row, we also wanted to have a 1 as well, and we want a 0 below it. So what we can do here, if I want to change this number into 1, I can just divide this entire row by negative 4. So we can write this either as negative 1/4 times row 2, or you can write it as row 2 divided by negative 4. Those notations mean the same exact thing. Here you don't have to write the arrow to say where your answer is going, because since you're only dealing with one row, the assumption is your answer is going in that same row. So 0 divided by negative 4 is 0. Negative 4 divided by negative 4 is 1. 1 divided by negative 4 gives us negative 1/4. And negative 7 divided by negative 4 gives us a positive 7/4. So always referring to our goal, 1 on the first row, we have that. 0, 1 on the second row, we have that. Now we need to change this value to 0 as well. And what we notice, if we look at row 2 and row 3, if I add these two rows together, that number will cancel out. So we can do row 2 plus row 3 and store that answer in row 3. So now row 1 is going to remain the same. Row 2 is going to remain the same. And the row that we're changing is that very last row. So 0 plus 0 gives us 0. 1 plus negative 1 gives us 0. Negative 1/4 plus 6. Remember that whenever you want to add a fraction and a whole number, we have to have the same denominators. So we have to change 6 so that its denominator is 4. And this number has to be 24 in the numerator. So negative 1/4 plus 24/4 is going to give us 23/4. Then we have 7/4 plus 27/27. Whenever you're adding fractions, we have to have the same denominator. And what we did on number 6 was we multiplied the top and the bottom of that number. Any whole number you can always put over 1. So here our denominator is 4, and our numerator, we have 108. So if we add those two numbers together, we have 115/4. So it might look a little intimidating, but just keep going. So checking out our goal, 1 on the first row, we still have that. 0, 1 on the second row, we still have that. 0, 0, we have those, but now we need a 1 here. So what we're going to do is to multiply that row by the reciprocal. So we're going to do 4/23 times row 3. So the first row is going to stay the same. Second row is going to stay the same. Third row we're going to multiply. So 4 over 23 times 23 over 4. 4's cancel out, 23's cancel out, and we're left with 1. Then we have 4 over 23 times 115 over 4. 4's are going to cancel out, and 115 divided by 23 leaves us with 5. So, it looked bad initially, but it's not as bad as you think. So, now, once we have met our goal, meaning our matrix is in row echelon form, now we change this back into a system of equations like our original problem. So remember, first column represents x, second column represents coefficient of y, third column represents coefficient of z, and our answers are in the last column. And z equals 5. So this gives us the indication that we are on the right track, because here is our answer for z. Z should be 5, and that's exactly what we have at this step. Now what we do is back substitution. So we're going to take 5 and plug it into our previous problem. So we'll have y minus 1/4 z equals 7/4. So when you're multiplying a whole number in a fraction, we put the whole number over 1 and multiply straight across. To solve this equation, our opposite of subtracting 5 over 7, 5 over 4, is we're going to add 5 over 4 on both sides. When adding fractions, we keep that denominator the same and add the numerators. So y is equal to 3. So we go back and confirm this with our answer that we had at the beginning. Y is equal to 3. We have that. Then back substitution again. We now have z from finishing our matrix. We plug that into the previous equation now that we have y, and then we work our way back up. That's our back substitution to the original problem. X minus y plus 2z equals 4. So we'll plug in the value of y, plug in our value of z. So x minus 3 plus 10 equals 4. And x plus 7 equals 4. So solving for x, our opposite is as adding 7. We're going to subtract 7 on both sides. So x is a -3. So there's our solution. -3, 3, and 5.